Hey, welcome back. Today we'll be doing a more enhanced version of the trigonometric graph sketching problem. So this is the question. Sketch the graph of y equals to modulus sine x plus 2 for this range, alright, in between 2 pi and 0. And then from the graph we need to find the range of t so that this given equation has no roots. Alright, so basically we can separate this question into two parts. The first part is to sketch a graph, and the second part is to find the value of t, and such that this equation will not have roots. Alright, so let's do the first part together. So now you can see that the frequency is 1, alright, because it's just a single x here. Which means I will be drawing one full cycle only. So now we will take a look at the amplitude. The amplitude is 1, okay, as you can see there's no number, which means by default it is 1. So which means you have the highest point of 1 and the lowest point of -1. Okay, let me fill the axis. And then you have the modulus. Modulus means you have to flip all the negative to become positive. So at this point, right, it will be flipped. And let me use another color to represent. Let's say I use a red color. Alright, so after this bottom part has been flipped, we will have this curve. Alright, so we have done the modulus as well. Now we will do the plus 2. Plus 2 basically it means we are shifting the curve upwards by 2 units. So again, I will focus on all these 0 points and turning points, and I will track their movements. Okay, so from 0, right, if you plus 2 units, you get up to 2. Okay. If it's 1, you get up to 3. So same goes for 0, 1, and 0. You become 2, 3, and 2. Alright, so basically we're just shifting the whole curve upwards by 2 units, and then we get this new curve. Okay, so in the end, I'm just going to redraw this so that it won't look so messy. I will change back to white. Alright. So you will have 2 and 3. Draw the curve. Alright, here you go. You have the final curve. And don't forget to list down the axes. The range of x is in between 2 pi and 0, and the frequency is 1. So the end of this curve is 2 pi. And then so half of it will be pi. That's why we know here is pi and here is 2 pi. Okay, now before we move on to the second part, right, let us revise. Okay, how do we find the roots back then when we were in Form 4? Okay, so in Form 4, we will have questions like x squared minus x minus 2 equals to 0. And then they will ask us to find the roots. And then we know that finding the roots is actually finding the intersection between the curve and the axes. Alright, so these intersection points, we call it as roots. The reason why we find the intersection points specifically at the x-axis is this. We can understand the given equation as the intersections between two graphs. Alright, the first graph comes from the left side and the second graph comes from the right side. The first graph is y equals to x squared minus x minus 2, which is a graph for the curve. And the second equation, y equals to 0, which is the x-axis. That's why we know that we have to find the intersection at the x-axis, alright, since the second equation is y equals to 0. Essentially, we can say that finding the roots is like finding the intersection points between the equation on the left and the equation on the right. So same goes for this question. When we are asked to find the roots, right, we are actually interested in whether this modulus sine x intersects with the t minus 2 or not. Alright, let me erase this part. So we're looking for the intersection between modulus sine x and t minus 2. Okay, but bear in mind, the question asks us to find the intersection from our graph at here. Okay, so the graph that we have drawn, right, is not modulus sine x, but it is modulus sine x plus 2. Therefore, we need to make a small adjustment here by shifting the negative 2 to the left. Now, we have the graph that we have just drawn to be on the left of the equation, okay? And the question asks, what is the range of t such that this equation will have no roots? In other words, they are asking, what is the range of t so that y equals to modulus sine x plus 2 and y equals to t will not intersect with each other. Alright, so we have drawn this graph, which is this one. Now we just need to find where should we put our t so that it won't intersect with this curve. Let's say we assume t is equal to 3, means that your y will be a constant, and you will have a horizontal line like so. And this line will touch the curve at 2 points. Okay, so in this case, we still have roots. So t cannot be 3, okay? Or let's try 2. If let's say t is 2, then we will have another horizontal line like so. And subsequently, we will have 3 roots. As you can see from here, the line t equals to 2 has 3 intersections. So we are still getting roots. Please be reminded that we don't want to have any roots. Therefore, you want your t to be away from the graph. So in what range of t your line will be away from the graph? It is when your t is more than 3 or less than 2. Let's say when your t is 4, your line will be above the curve like so. And then it is not intersecting. It is not intersecting with the curve at all. So another range is that when your t is less than 2, let's say your t is -1, alright? It is at bottom here. So it's not touching or intersecting the curve at all. So from here, we can see that when your t is anywhere more than 3, or your t is anywhere less than 2, you will have no intersections and hence there will be no roots. Therefore, the final answer is t less than 2 and t more than 3. That's all for this question, and I have a question for you. Find me the range of t so that we will have 4 roots. Okay? Comment your answer down below and I will see how many of you get the correct answer. That's the end for this lesson. Don't forget to like and subscribe to my channel, and also share to your friends that find trigonometric functions to be difficult. Yep, I will see you in the next one. Bye.